Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology, Peshawar. In this video, I'll be talking about limit of a function, and the first part is I'll be talking about existence of limit of a function and finding limits of a function. The first I'll give you a brief concept of limits. So what does it mean? Finding a limit at a point of a function and value of a function at that point. Okay, so let's suppose we are given a function f of x is equal to x square minus 1 divided by x minus 1. And if we want to find the value of this function at x equal to 1, so obviously you would see f of 1, which is equal to 1 minus 1 divided by 1 minus 1, and that basically make a form 0 by 0, and this 0 by 0 form is known as indeterminate form. Okay, and which basically means this value does not exist. So this function has no value, or it's not giving you any value at x equal to 1. Okay, so now we basically want to check what would be the behavior of this function as x approaches to 0, which basically means what is the behavior of this function in the neighborhood of this function, this number 1, which we take 1 minus alpha and 1 plus alpha, where alpha is a very small positive number. Okay, so what would happen, or what is the behavior of this function near this point 1? So geometrically you see that if you consider this interval, a small interval, this is plus alpha and this is minus alpha, so we take 1 minus alpha and 1 plus alpha. So in this interval, what is the behavior of a function? So you see, behavior of this function near this point is what? It's almost same as that function x plus 1. And why do we have? This is the graph of y is equal to x plus 1 except x equal to 1. ठीक है, x इक्वल टू 1 के अलावा बाकी जो ग्राफ बन रहा है वो किसका बन रहा है? वो x प्लस 1 का ही बन रहा है. और ये हमें पता कैसे चलता है? वो यहीं से चलता है बिकॉज वी कैन फैक्टराइज दिस x माइनस 1 x प्लस 1 divided by x minus 1. So we cancel these together, so we get x plus 1. So graph of this function f of x is equal to x square minus 1 divided by x minus 1. ये सेम होता है जैसे ही ग्राफ होता है x plus 1 का everywhere except x is equal to 1. Because at x equal to 1, what happens, this function is not defining any value, whereas this function x plus 1 will be giving you a value that is equal to 2. तो इन दोनों फंक्शन में फ़र्क जो आता है वो सिर्फ x इक्वल टू 1 पे आता है, बाकी सेम होगा. इसका मतलब ये है कि इस फंक्शन का नाइबरिंग बिहेवियर जब हम उसकी नियर 1 बात करते हैं, चाहे लेफ़्ट पे बात करें चाहे राइट पे बात करें, उसका बिहेवियर सेम होगा जैसे ही x प्लस 1 का होता है. एंड दिस नाइबरिंग बिहेवियर इज़ बेसिकली नोन एज लिमिट ऑफ ए फंक्शन. किसी पॉइंट पे फंक्शन की वैल्यू का मतलब एग्जैक्टली उस पॉइंट पे फंक्शन की वैल्यू की बात होती है. जबकि हम जब नाइबर में बात कर रहे हैं, यहाँ से लेकर यहाँ तक हम बात कर रहे हैं, तो उस केस में हमारा मकसद होता है फाइंडिंग लिमिट. So when you say what is the behavior of this function near x equal to 1, that basically mean you need to find x goes to 1 f of x f of x. इसकी क्या वैल्यू होगी? Okay, so you see that's the graph of y is equal to x plus 1, and this is the graph of y is equal to x square minus 1 divided by x minus 1. दोनों का अगर आप देखेंगे यहाँ पे, if you consider above x equal to 1, you consider below x equal to 1, दोनों के जो ग्राफ्स हैं they are same, राइट। यू सी दैट यहाँ पे जो वैल्यू है, यहाँ पे जो वैल्यू है और यहाँ पे वैल्यू है, दे आर एग्जैक्टली सेम। सिर्फ जो मसला आ रहा है, जो पॉइंट है जहाँ पे ये डिफाइन नहीं है, वो x इज इक्वल टू 1 पे है। इस केस में x इक्वल टू 1 पे फंक्शन की वैल्यू 2 है, जबकि इस केस में हमारे पास फंक्शन की वैल्यू हम कहते हैं डज नॉट एग्जिस्ट, राइट। आई सिंपल यूज DE जहाँ पे भी मैं डज नॉट एग्जिस्ट की बात करूँगा, राइट। सो ये थोड़ा सा इसका बेसिक कंसेप्ट होता है। अब इसमें 3 तरह की केस हमारे पास आ सकती हैं। यूजुअली वी टॉक अबाउट इन दोनों के बीच में क्या रिलेशन है, एक पॉइंट पे फंक्शन की वैल्यू और उस पॉइंट पे फंक्शन का लिमिट। तो इसको अब अंडरस्टैंड करने के लिए आपकी ये 2-3 ग्राफ मैं आपको प्रेजेंट कर रहा हूँ। अगर हम इस फंक्शन की बात कर लें तो इस फंक्शन की जो नाइबरिंग बिहेवियर है, एज वी अप्रोचेस टू 1 फ्रॉम ईदर साइड, that what I said is 1 minus this is 1 minus delta or 1 minus epsilon, and the second point is 1 plus epsilon. If he approaches to this point from right side or left side, in both cases the function is approaching towards 2. So that means the limit of this function, it has a neighboring behavior, but at exactly x equal to 1 इसकी value defined नहीं है। अगर हम इस नेक्स्ट जो इसका ग्राफ है, इस फंक्शन की हम बात करें तो इस फंक्शन के केस में क्या हो रहा है कि लिमिट तो वही सेम आ रहा है, इधर से भी जा रहे हैं, इधर से भी जा रहे हैं, द ग्राफ इज अप्रोचिंग टूवर्ड्स 2 फ्रॉम ईदर साइड। तो इसका लिमिटिंग बिहेवियर नाइबरिंग बिहेवियर तो 2 ही है, is like in this case, but the function value is also defined in this case, and that is what it is given is 1. That means the function is giving you 1 जब हम x को 1 लेते हैं। अगर x 1 ना हो तो इसका बिहेवियर वही सेम होता है जैसे x plus 1 का होता है। And the third case is what we consider x plus 1. So you see as a whole function, इधर से भी इधर यहाँ पे क्या हो रहा है, यहाँ से क्या हो रहा है। इन बोथ केसेस नाइबरिंग बिहेवियर वही आता है जो पिछले केसेस में है। हाँ, फ़र्क सिर्फ यह आ गया कि यहाँ पर फंक्शन की वैल्यू 1 पे भी डिफाइंड है और वो उसी के बराबर है जो लिमिट है। तो यहाँ पे आप देख सकते हैं, यहाँ पे जो वैल्यू इसकी है वो 2 के बराबर है, यहाँ पे 1 के बराबर है और यहाँ पे एग्जिस्ट ही नहीं कर रही। तो यहाँ से हम ये कंक्लूड कर सकते हैं कि किसी भी पॉइंट पे फंक्शन की वैल्यू f ऑफ a और लिमिट x गोज़ टू a f ऑफ x, इनका आपस में उनकी एग्जिस्टेंस, नॉन एग्जिस्टेंस, इक्विवेलेंस का आपस में कोई रिलेशन नहीं है। मतलब इसका ये है कि किसी पॉइंट पे फंक्शन की वैल्यू एग्जिस्ट करेगी, उसका नाइबरिंग बिहेवियर डिफाइंड नहीं होगा। किसी पॉइंट पे फंक्शन की लिमिटिंग वैल्यू डिफाइंड होगी, ठीक है, लेकिन वहाँ पे फंक्शन की वैल्यू डिफाइंड नहीं होगी। किसी पॉइंट पे ऐसा भी पॉसिबल है कि ये दोनों वैल्यूज़ डिफाइंड होंगी लेकिन दे विल बी डिफरेंट, राइट। दोनों डिफाइंड होंगी लेकिन देयर इज़ अ पॉसिबिलिटी दोनों डिफाइंड होंगी लेकिन इक्वल भी हो सकती हैं, राइट। सो इसका आपस में कोई ख़ास इस तरह ताल्लुक़ नहीं होता। लेटर ऑन जब हम कंटिन्यूटी की बात करेंगे तो उस केस में क्या हो जाएगा, ये हमारे पास इन दोनों का सेम होना ज़रूरी होगा फिर, राइट। ओके, so let's talk about some more functions and we check their neighboring behavior. So you see in this case the function is defined as x, for x less than 0 the function is defined as 0, and for x greater than or equal to 0 the function is defined as 1. So we want to check what would happen if we take the neighborhood or we check the neighboring behavior of function u of x in this case. So you see the left side graph will be what? That is simply a function x equal to 0. So the graph will be along x-axis like that. This is the graph of x equal to y, u of x is equal to 0. Whereas on the right side its value is 1. So you see in this case the value is, from here we approach to 0. तो जो ग्राफ हमारे पास बनेगा वो हमारे पास ये वाला हो जाता है। इसका मतलब यह है कि जब हम इस 0 पे इसकी बात करेंगे, इसके नाइबरिंग बिहेवियर की, तो हम जब लेफ़्ट से अप्रोच कर रहे हैं, दैट मीन्स इफ़ यू आर टू द लेफ्ट ऑफ दिस वन दैट इज़ 0 माइनस एप्सिलॉन समवेयर हियर, तो इन दिस इंटरवल इट इज़ गिविंग यू 0 वैल्यू। But when you approach to this point from right side, which means 0 plus epsilon part of the interval, in this case the function is giving you 1. So from one side its behavior is 0, where from the other side इसका behavior क्या है, 1 है. So we don't have a identical or same behavior. So in this case we say that limit or neighboring behavior of this function at x equal to 0 does not exist. That's u of x does not exist. Okay, so now what would happen if you want to find the value of this function at x equal to 0? So at x equal to 0 the function is defined, that is in this interval, so f of 0 in this case will be equal to 1. Let's consider another function, that is g of x, which is equal to 1 over x when x is not equal to 0, and it is 0 when x is equal to 0. So graph of this function is like that. You see it's same as 1 over x, but 1 over x is not defined at x equal to 0, and so we have defined it at x equal to 0. Its value is what? That is 0. So in this case g of 0, that is defined as 0, whereas if you want to find we want to check the behavior of this function is x goes to 0 from left side, so g of x is going towards minus infinity. You can see, you can observe that from the graph. The graph, if as we approach to 0 from left side, the graph is going towards minus infinity. Similarly, if you approach to 0 from right side, the function is approaching towards plus infinity. As we approach to this, इस साइड से अगर हम देख लें तो ये जो function है ये ऊपर की तरफ जा रहा है towards plus infinity. So in this case the neighboring behavior from left side is minus infinity, it's plus infinity. तो दोनों same नहीं है, therefore we say कि ये limit जो है, limit x goes to 0, in this case 1 over x, it doesn't exist. Okay, if you consider f of x is equal to 0 when x is less than or equal to 0, and it is signed 1 over x when x is greater than 0, right? So in this case you see again the graph of this function is like that. So from the left side, as we approach x approach to 0 from left side, the graph is approaching towards 0. So it means the left behavior is what of the function is 0. Whereas if you approach to 0 from right side, from this side, the graph is you see oscillating between minus 1 and 1, as sin 1 by x is oscillating between minus 1 and 1 as x is getting smaller and smaller, right? So in this case we say that if as we approach to 0 from right side, the graph is not converging, the graph is not approaching towards a fixed number. So in this case we also say that limit does not exist, or its neighboring behavior does not exist. So we are having three different cases. In this case we are having jump at x equal to 0. In this case we have a discontinuity at x equal to 0. Both this is also discontinuity, but in this case obviously we are moving towards to different levels. One is plus infinity, the other one is minus infinity, and in this case we are having oscillating behavior of the function. So in all these three cases limit of a function does not exist. Geometrically अगर आप उसको देखना चाहें तो अगर कहीं पे jump आता है, कहीं पे asymptotes आते हैं, right, if you are having a slope of asymptote in a different way, तो और या हमारे पास oscillating behavior होता है किसी function का, तो इन तीनों cases में function का limit जो होता है या जिसको हम neighboring behavior कहते हैं वो exist नहीं करता. These are some rules of limits. There are some laws of limits. Simple अगर हम limit को find करते हैं, once you came to know the limit exists and you want to find limit, so we can have a sum of functions, we can have difference of two functions, we can have a function multiplied by a constant, we can have a product of two functions, we can have a quotient of two functions, we can have a power of a function, whatever. So in all these cases, how do we do that? If you want to find limit of a function at a point and we are having sum of two functions, so finding first sum of functions then applying limit is same as applying limit first and then taking their sum. पहले लिमिट फाइंड करें, इसके बाद फिर उसका सम ले लें, या पहले आप उनका सम ले लें फिर इसका लिमिट फाइंड करें, दोनों केस में सेम ही होता है। अगर यहाँ पर माइनस आ जाए तो सेम माइनस यहाँ पे आ जाएगा, सेम थिंग हैपेंड इन सबट्रैक्शन एज वेल। यही चीज़ अगर यहाँ पे इन दोनों फंक्शन के बीच में मल्टीप्लिकेशन हो तब भी यही चीज़ है। अगर इनके बीच में डिवीज़न है तो सिर्फ ये चीज़ है कि अगर ये लिमिट एग्जिस्ट नहीं कर रहा तो फिर हम ये रूल अप्लाई नहीं कर सकते, जी ऑफ एक्स का एग्जिस्ट होना ज़रूरी है और ये ज़ीरो के बराबर ना हो, तब हम उसको ये अप्लाई कर सकते हैं। इसका मतलब वही है कि हम एफ पर अलग से लिमिट अप्लाई करें, जी पे अलग से लिमिट अप्लाई करें, या दोनों के पहले क्वोशंट लें और फिर लिमिट अप्लाई करें। द सेम थिंग इज़ डन विद पावर एज वेल एंड विद रूट एज वेल। So for example, this is the function whose we want to limit of this function. अब अगर आप इसमें सी डायरेक्ट हम पुटिंग कर रहे हैं यहाँ पे, तो आ जाएगा 1 स्क्वायर प्लस 1 माइनस 2 divided by 1 minus 1, so this will give you 0 by 0. So we are leading towards, or we are led towards what? Towards 0 by 0. So whenever we have 0 by 0 at exact point, so the limit would be found is by checking the neighboring behavior. So neighboring behavior का मैंने अभी थोड़ी देर पहले ही कहा था कि आप क्या करते हैं, इस फंक्शन को फैक्टराइज करते हैं, लिमिट x goes to 1, okay, and this can be factorized as x square plus 2x minus 2 divided by x into x minus 1, which is same as limit x goes to 1 x plus 2 minus 1 x plus 2 divided by x into x minus 1, which might be simplified as limit x goes to 1, this is x plus 2 x minus 1 divided by x into x minus 1. We cancel these together. That is limit x goes to 1, we have x plus 2 divided by x. Then applying limits, we get 1 plus 2 divided by 1, that is equal to 3. So limit of this function is equal to 3. यहाँ पर एक बात आपने नोट करना है, अगर ये फंक्शन है और आपसे कोई पूछे व्हाट इज़ f of 1, तो f of 1 हमारे पास क्या होगा, वो एग्जिस्ट नहीं करेगा, बिकॉज जब हम डायरेक्टली इसमें 1 पुट कर रहे हैं तो वी आर गेटिंग 0 by 0, तो उसके लिए हम ये फैक्टराइजेशन नहीं कर सकते। यू कैन नॉट से कि अगर मैं 1 के लिए फैक्टराइजेशन करूँ तब तो यही वैल्यू आएगी, तो ऐसा आप नहीं कर सकते, ठीक है। यू कैन डू दैट ओनली इन द नाइब, बिकॉज एज एक्स इक्वल टू 1 एंड यू वांट टू यूज दिस फार्मूला और दिस फंक्शन, इट विल गिव यू 0 by 0। लेकिन लिमिट फाइंड करने के लिए हम क्या करते हैं, वी आर लुकिंग फॉर द नाइबरिंग बिहेवियर, तो इसके लिए हम एक और फंक्शन ढूंढते हैं जिस फंक्शन का नाइबर बिहेवियर और इस फंक्शन का नाइबर बिहेवियर दोनों सेम है, तो वो फंक्शन x प्लस 2 डिवाइड बाई एक्स होता है, ये वो फंक्शन है, ठीक है, x प्लस 2 डिवाइड बाई एक्स, और ये इन दोनों का जो नाइबरिंग बिहेवियर एट x इक्वल टू 1 है वो सेम होता है, एग्जैक्टली 1 पे इन दोनों की वैल्यू डिफरेंट होती है। If you talk about this one, so in this case again if you put x equal to 0, what would happen, we are having again 0 by 0 if you want to find exact value at x equal to 0. So what do? Whenever we have 0 by 0, so let's check whether the function has any common factor. If not, then what do? We go for rationalization. So we can rationalize this function, right, multiplying and dividing by the conjugate of this function, which is obviously that is under root x square plus 100 plus 10 and dividing with same as well, x square plus 100 plus 10. So we have limit x goes to 0, that's a minus b into a plus b, so we get x square plus 100 whole square minus 10 square divided by x square into under root x square plus 100 plus 10. We can cancel these together, and then we have 10 square and 100 will cancel each other, So we get this is equal to limit x goes to 0, x square divided by x square into under root x square plus 100 plus 10. So we can cancel these together and then we apply limits. So we get 1 divided by under root 0 plus 100 and then plus 10, which give you 1 by 20, because from here we get 10, so 10 plus 10 is 20. So limit of this function will be 1 by 20. So we discussed two cases. One is we have 0 by 0, then check for common factor. We have 0 by 0, then we do rationalization if it involves square root of something. So we do rationalization in that case. In third case, if we get 0 by 0 form, so what do? We can use sandwich theorem. The sandwich theorem is saying if we have two functions like that, and the third function whose limit is required is between these two functions. If you know limits of these two functions at a specific point, जिस point पे हमारा इस function का limit चाहिए, तो क्या करते हैं, इन दोनों का लिमिट उस पॉइंट पे सेम हो तो वही लिमिट इस फंक्शन का भी होगा। मतलब यह है कि आपके पास एक फंक्शन है और आप उसका लिमिट फाइंड करना चाहते हैं x इक्वल टू सी, लेकिन आप डायरेक्ट ना तो उसमें फैक्टराइजेशन हो सकती है और ना रेशनलाइजेशन, और डायरेक्ट हमारे पास 0 बाई 0 आ रहा है, तो हम क्या करेंगे, विल बी लुकिंग फॉर अनदर फंक्शन, टू फंक्शंस जिनके लिमिट्स सेम हो उसी पॉइंट पे और वो इस फंक्शन को बाउंड कर रहा हो। ठीक है, सो यू कैन फाइंड वन फंक्शन, लेट्स सपोज g ऑफ x है, द अदर फंक्शन इज h ऑफ x है, and that one is bounded above the function and the other one is bounding below the function. So the limit of these two functions, ऐसे फंक्शन आपको चाहिए जिनके लिए लिमिट एग्जिस्ट भी करे, आप फाइंड भी कर सकते हो, तो इसका भी वही लिमिट होगा, एंड दैट इज कॉल्ड सैंडविच थ्योरम. We can see it geometrically. Geometrically, you see we have one function that's h, the other function is this one g, and f is between these two functions. Whichever the shape of function is, we don't mind. So if limit at x equal to c, h and g both are, if that is equal to L, then limit of this function f will also be L. This is something called sandwich theorem. For example, if you want to find a limit of this function u of x, whatever or whichever form of this function is, it could be very complex, right? लेकिन हमें इन दोनों का लिमिट्स पता है और ये हमें पता है कि u of x जो है वो इन दोनों फंक्शंस के बीच में है. ओके, तो इस केस में हम क्या कर सकते हैं, जो इसका लिमिट है x goes to 0, so x goes to 0 1 minus x square by 4, and limit x goes to 0 1 plus x square by 2, both of them is equal to 1. So if you have any complex function for u of x, it will also be equal to 1. जो भी इसका फॉर्म हो, जिस फॉर्म में भी हो, लेकिन ये कंडीशन सेटिस्फाई करेगा कि वो इन दोनों फंक्शंस के बीच में होगा. The same thing we can use the same concept for limit x goes to 0 sine x by x as well, and we know that this limit is equal to 1. So this limit, अगर हम डायरेक्ट करना चाहें तो डायरेक्ट इसकी वैल्यू 0 by 0 आती है. अगर हम पुटिंग करेंगे x equal to 0 को इधर भी पुट कर दें, इधर भी पुट करें, so we get 0 by 0. But the neighboring behavior of this function is what? That is 1, and that is also proved by what? By using sandwich theorem. राइट, उसके लिए हम दो फंक्शंस ढूंढते हैं जिसके लिए ये जो फंक्शन है उन दोनों के बीच में लाई करता है. Okay, so let me discuss some questions or few questions from exercise 2.2 of Thomas Finney book. Right, the first questions are about the existence of limit. The question number 1, for the given function g of x, which is graphed here, we want to find what about limit x goes to 1, whether this exists or it doesn't exist. Similarly, x equal to 2, x equal to 3, and x equal to 2.5. So if you see, if you want to check graph behavior, neighboring behavior at x equal to 1, so if you approach to x equal to 1 from left side, right, the function is approaching towards 1. See, this is 1. As we approach to x equal to 1, from left side the graph is approaching towards y is equal to 1. But if you approach to the same point from a right side, the graph is going towards 0. So it means the left hand behavior is what that is 1, whereas the right hand behavior is what that is 0. या इन अदर वर्ड्स हम ये कह रहे हैं कि इस पॉइंट पे फंक्शन जो है उसका जंप है, तो जो मैंने कहा था कि अगर किसी पॉइंट पे जंप आ जाता है वहाँ पे फंक्शन का लिमिट एग्जिस्ट नहीं करेगा। तो ये जो फर्स्ट पार्ट है इसमें हम कह रहे हैं कि लिमिट डज नॉट एग्जिस्ट। Whereas at x equal to 2, if you check the left behavior of the function, it's going towards 1. Right side behavior भी check करेंगे तो दोनों साइड से वो एक ही पॉइंट पे आ रहा है, that point is 1, so this limit is equal to 1. और इस पॉइंट पे फंक्शन की वैल्यू भी 1 के बराबर है। अगर g of 2 फाइंड करना चाहेंगे तो वो भी 1 के ही बराबर है। Similarly, if you want to find limit at x equal to 3, इस पॉइंट पे अगर हम बात कर रहे हैं तो अगर हम लेफ्ट से अप्रोच कर रहे हैं तो वो आ रहा है 0 की तरफ ग्राफ। अगर हम राइट से अप्रोच कर रहे हैं तो ग्राफ आ रहा है 0 की तरफ, यानी इस पॉइंट पर भी जंप नहीं है। होल तो है लेकिन जंप नहीं है, तो इसका मतलब ये है कि इस पॉइंट पे लिमिट जो है वो 0 के बराबर है। जबकि इस पॉइंट पे फंक्शन की वैल्यू अगर हम g ऑफ 3 फाइंड करना चाहते हैं तो इस पॉइंट पे जो फंक्शन की वैल्यू है वो 1 के बराबर है। तो ये दोनों का बराबर होना लिमिट के केस में ज़रूरी नहीं है। अच्छा, 2.5 पे अगर हम बात करें तो 2.5 यहाँ पर एक पॉइंट होगा, सो इट इज़ समथिंग लाइक दिस वन। तो यहाँ पर ये एक पॉइंट है, ओके, दिस इज़ द पॉइंट। अब इसमें अगर अगेन हम लेफ़्ट से अप्रोच कर रहे हैं तो ग्राफ इधर से आ रहा है, अगर राइट से अप्रोच कर रहे हैं तो ग्राफ अगेन सेम पॉइंट की तरफ जा रहा है, जो कि यहाँ पे 2.1.5 समथिंग 0.5 होगा अप्रॉक्सीमेटली। तो हम यहाँ पे कह सकते हैं कि इस केस में भी लिमिट जो है वो एग्जिस्ट कर रहा है और वो वैल्यू क्या है, दैट इज़ 0.5 अप्रॉक्सीमेटली। एंड फंक्शन की जो वैल्यू है वो भी हमारे पास इस केस में 0.5 ही है। सो g ऑफ 2.5 इज आल्सो इक्वल टू 0.5। Okay, so if we talk about this question number 3, again we are looking for finding limits at different point or different position from the graph. Okay, and there are some more questions as well. So you see, first question is say, what about limit x goes to 0 f of x? So you see, do we have jump at this point? So the question is no, we don't have a jump because we are simply having a hole, but it's not a jump. So if you approach to 0 from left side, the graph is going towards 0. If you approach to 0 from right side, the graph is going towards 0 as well. So it means this limit exists, right? So the first question, you have simply true or false. So the first one is what? That is true, right? What about the second one? Limit x goes to 0 f of x, that is equal to 0. So if you approach to 0 from left side, it is going towards 0. Approaching from right to this point, it is also going towards 0. So this is also true. Value at this point is equal to 1. If you want to find f of 0, that is equal to 1. So what about limit at this point is 1? So no. If limit the first one, this part is true, तो ये हमारे पास कभी ट्रू पेयर नहीं हो सकता। किसी भी पॉइंट पे फंक्शन के लिमिट जो है वो यूनिक होता है। वी कैन नॉट हैव टू डिफरेंट लिमिट्स एट अ पॉइंट। If you talk about limit x goes to 1, the next part, so at x equal to 1, we are having jump. You see that we have one part here, second part here. So there is a jump at x equal to 1. It means limit at this point does not exist. So if limit does not exist, so can it be 1? The answer is obviously no. So this is true, false. Can it be 0? Again, no. It's false because you see, अगर limit exist नहीं कर रहा तो वो 1 या 0 नहीं हो सकता। So what about limit it from x equal to -1 to +1? Do we have any jump in the graph from x equal to -1 to x equal to 1? We have a jump at x equal to 1, but we talk about this open interval from -1 to 1. So 1 is not included. So we say limit x goes to c f of x exists at every point. The answer is, in this case, it is true because there is no jump in this case from -1 to 1, excluding -1 and 1. We say limit x goes to 1, f of x does not exist. So already I told you that x equal to 1, limit exist nahi kar raha, so that is true. What about f of 0 is equal to 0? As I said, f of 0 is equal to 1, because 0 पे इस function की value जो है वो क्या है, वो 1 है, it is not 0, so this is false. F of 0 is equal to 1, that's all it told, so it's true. F of 1 is equal to 0. If you check the value of function at this point, so at 1 it is equal to 1, so it is true. F of 1 is equal to minus 1, so you see that it's a whole here, so it means at x equal to 1, if the value is 0, it cannot be minus 1, otherwise it will not become then function. For a function, we should have a unique value at each point. Okay, so in these question 5 and 6, we want to check whether these limit exist or not. We have to check they don't exist. So at the moment, what do? We want to check them by plotting these functions. So in question 5, this function is basically equivalent to what? When x is less than 0, this is x, whereas x absolute is minus x for x less than 0. So this function is basically same as minus 1. When x is greater than 0 or equal to 0, we don't have to take equal to 0. So this will be x divided by x absolute is plus x, so we have 1. Because you should know that x absolute is defined as this is equal to x when x is greater than or equal to 0, it is minus x when x is less than 0. So that's why this function is equivalent to what? This function is equivalent to, this is minus 1 when x is less than 0, this is plus 1 when x is greater than 0. So it's not x, it's 1. So if we draw a graph of this function, so graph of this function will be, when we are to the left, so we take whole here, and this will give to the right, it will be 1, whereas to the left, if you take this one, so it's minus 1. So you see at x equal to 0, we are having jump approaching to 0 from left side, and right side will give you different values. So if you approach to this from left side, x by x absolute give you minus 1. When you approach to this from right side, it give you what? This plus value. So both are not same, therefore we say this limit does not exist. That's the proof. Similarly, if you want to draw the graph of 1 over x minus 1, so first we check about graph of 1 over x. So you should know graph of 1 over x is something like that. But if we draw the graph of 1 over x minus 1, so that will become something like that. It's a shifting the graph of 1 over x 1 unit to the right. This is graph of 1 over x, this is graph of 1 over x minus 1, because this graph is shifted 1 unit to the right. So we see it x equal to 1. If you approach to 1 from right side, the graph, this graph is, it is a vertical as I'm told, so that this is going towards plus infinity, and if you approach to 1 from left side, it is going towards minus infinity. So are having two different limits. Is x approach to 1 from left, it is giving you minus infinity. But if x is approaching to 1 from right side, the function is approaching towards plus infinity. Therefore, we are saying this limit does not exist as well. So from question 7 to 10, we are having some relations which are relating the value of a function at a point and limit at that point. Okay, so the first number is saying, question number 7, it says that f of x is defined for all real value of x except x equal to c. Can anything be said about the existence of limit? So obviously we cannot say anything, because इनका आपस में कोई ताल्लुक नहीं है. अगर फंक्शन एक पॉइंट पे डिफाइंड नहीं है, तो वहाँ पे लिमिट एग्जिस्ट हो सकता है, नहीं भी हो सकता. तो इसका किसी पॉइंट पे एग्जिस्ट होना, डिफाइन होना या ना होना, it has nothing to do with the limit at that point. The same thing here, it says that this function is defined in this interval -1 to 1, right? And it is defined everywhere. It means it is also defined at x equal to 0 as well. So what about the limit at that point? So again, we cannot say anything about limit at that point. जैसे मैंने यहाँ पर एक्सप्लेन कर दिया कि अगर लिमिट किसी पॉइंट पे एग्जिस्ट कर रहा है तो उस पॉइंट पे फंक्शन की वैल्यू का उससे कोई ताल्लुक नहीं है। ये सम टाइम एग्जिस्ट करता है, लिमिट एग्जिस्ट नहीं करता। ये एग्जिस्ट करता है, लिमिट भी एग्जिस्ट करता है। ये एग्जिस्ट नहीं करता, लिमिट भी एग्जिस्ट नहीं करता। ये एग्जिस्ट नहीं करता, लिमिट एग्जिस्ट करता है। दे माइट, दोनों अगर एग्जिस्ट करते हैं तो ज़रूरी दे माइट बी डिफरेंट एज वेल। दोनों एग्जिस्ट कर रहे हैं और दोनों सेम भी हो सकते हैं, तो इनका आपस में कोई ताल्लुक नहीं है। The same thing in question number 9. It says if it's at a point x equal to 1, if the limit is 5 and f is defined at x equal to 1, तो obviously ज़रूरी नहीं है, अगेन मस्ट नहीं है, इट मे और मे नॉट बी डिफाइंड। अगर डिफाइंड है तो क्या वो 5 के बराबर होगा? तो अगेन एज आई सेड, ज़रूरी नहीं है कि वो 5 के बराबर होगा, बिकॉज वी हैव नथिंग इन कॉमन बिटवीन दैम। एंड सिमिलरली इफ f of 1 is equal to 5, क्या लिमिट एग्जिस्ट करेगा? सो अगेन मे और मे नॉट। अगर ये कर दे तो क्या वो 5 के बराबर होगा? अगेन मे और मे नॉट। सो इनका आपस में कोई ताल्लुक नहीं होता। So in question 23 to 42 in Thomas' book, we are finding limits, right? So you have to check simply, do we have 0 by 0 form? If yes, then look for some factorization or maybe rationalization. So if we talk about 23, so in this case we put x equal to 5, so we are getting 0 by 0. So it means we need to find these limits. This limit can be found as 5 x minus 5 divided by x square minus 25 can be factorized as x minus 5 and x plus 5. We cancel these together to get simply limit x goes to 5, 1 over x plus 5. That is equal to 1 over 5 plus 5, 10. So limit of this function is what? That is 10. We are value of the function at x equal to 5 does not exist. Same thing in question number 24. You will do factorization. In question 24, if you put x equal to minus 3, this is 0 and this is also 0. So it means it is 0 by 0. So we have to go for factorization. So this is x plus 3 divided by x square plus 3x plus x plus 3, which is equal to limit x goes to minus 3, it is x plus 3 divided by x plus 3 plus 1, x plus 3. X goes to minus 3, it is x plus 3 divided by x plus 3 into x plus 1. So we cancel these together. So this function have same limiting behavior as of this function 1 over x plus 1, and that limiting behavior is minus 1 over 2. Okay, so same thing in question 25, 26 and so on. Let me do question number 30. Question 30, this one. So we have question 30 here, that is limit y goes to 0, it's 5y cube plus 8y square divided by 3y power 4 minus 16y square. If you put y equal to 0, we are getting 0 by 0. So we have to find this limit, so we can do in this way. Let's look for the common factor. So y square is common, 5y plus 8 divided by, similarly y square is common in the denominator as well. So we have 3y square minus 16. We can cancel these together. The common factor will be cancelled and then applying limit. So we get 0 plus 8 divided by 0 minus 16, which give you minus 1 by 2. So limit of this function is minus 1 by 2. So more questions. I see question number 31. in this case we are finding limit x goes to 1, x power minus 1, which is 1 over x minus 1 divided by x minus 1, which again give you 0 by 0. So this limit is basically same as limit x goes to 1 by taking LCM in the numerator. So we get 1 minus x divided by x, and then we may take minus common from it later on. So we have x minus 1. तो हमारे पास आ जाएगा ये लिमिट x goes to 1 माइनस कॉमन निकालें तो we get x minus 1 divided by x into x minus 1. We can cancel these together, and then applying limit would give you minus 1. Same thing in 32, we'll simply taking LCM in the numerator, and then we'll cancel the common factor. 33 factorization, 34 factorization, and so on. If you go for 35, so in question 35 we are having limit x goes to 9 under root x minus 3 divided by x minus 9. If you put x equal to 0 again, 3, we get x equal to 9, we are getting 0 by 0, and it involves square root, so we will be multiplying and dividing by the conjugate. We do rationalization, multiplying by under root x plus 3 under root x plus 3. So its limit x goes to 9, we have x minus 9, this is x minus 9 into under root x plus 3. This is because of what? This is a minus b into a plus b, that will give you under root x square minus 3 square, which give you this one. And then we cancel these together, applying limit, so we get 1 over under root 9 plus 3, that is 1 over 3 plus 3 is 1 over 6. And so on. We do same thing here. We do rationalization. You will be doing rationalization in the denominator, rationalizing the numerator, rationalizing numerator, rationalizing denominator, and same thing here and here as well. If you have any query, you can simply post a question in the comment box. I'll get back to you. So thank you very much.